Electromagnetic fields is what we're going to be talking about and how they impact our bodies. And one thing that's very important is that electronically generated EMFs are coherent. That is, they're put out in a particular vector direction with a particular frequency, phase, and polarity. And for all of those reasons, they produce very strong electric and time-varying magnetic forces, which can then impact the cells of our bodies. Most natural EMFs are incoherent and basically produce only minuscule forces. So this coherence is very important, and it is essential for the ability to use EMFs for wireless communication. So the same thing that causes impacts on our bodies is the same thing which is required for wireless communication. And so we're going to be talking about that, and we're also going to be talking about the role of pulsation, because wireless communication uses modulating pulses to communicate the information. And those modulating pulses make these EMFs much more biologically active, basically because the peak intensities are the crucial thing, not the average intensity. So, okay, let's see. How do I, okay. So the first paper that I published on EMS was published in 2013. And it showed that there were a large number of studies where non-thermal effects of microwave and also other frequency EMFs could be blocked or greatly lowered by what are known as calcium channel blockers. These are blockers that are specific for blocking what are called voltage-gated calcium channels, or VGCCs. And what those studies show is that the EMFs are acting by activating these VGCCs, and therefore, if you block them, you can block the effects, or at least greatly lower the effects. Now, that paper has been now cited 400 times in the according to Google Scholar. So it's been very widely recognized. This mechanism is very widely recognized in the scientific community, as shown by this very large numbers of citations. And so that's important. And now what I'm going to do is kind of outline for you how this thing works. And this is going to be a little bit esoteric, but the basic idea is that those channels, and let me say it's not just the calcium channels, but they're also voltage-gated sodium channels and potassium channels and chloride channels that are also activated by the EMFs, but most of the effects are produced through the calcium channels. And they have a structure called the voltage sensor, and they contain a bunch of helices in 4 different domains. So if you look at this structure and this structure and this one that's going off the screen here, they're very, very similar. So there are 4 of them, and there are 4 helices, S4 helices, that have a lot of positive charges on them. And it's those positive charges on these helices, this one, this one, this one, and that one, that where the forces act to to cause these things to ratchet out away from the center, open the channel, and allow then ions to flow through into the cell. So we know a lot about how this thing works, and what I'm arguing is that both the electric forces on the EMFs and also the time-varying magnetic forces, which are also very important, act on those charges, on the charges on this helix and that helix, and that then something happened here. Okay, so how then let's see. Close that. Yeah. Okay. How then do you get biological effects? And the biological effects are all sort of described in this figure. So we have a variety of different EMFs here. They put forces on these voltage gated calcium channels, VGCCs, and they activate them. They open the channel, and you get large amounts of calcium flowing into the cell. And so you get very large increases in intracellular calcium as a consequence of that. Now, part of the reason why calcium flows into the cell is because typically in the cells of our bodies, under most conditions, the calcium outside the cell is about 10,000 times higher than the calcium inside the cell. So there's a huge flux of calcium going into the cell. And when that happens, you get pathophysiological effects shown here, that is damaging effects in the body. And they're produced mainly through two main pathways, this one and this one here. One of them is calcium signaling. So calcium signaling is very, very important in the cells of the human body and the cells of all animals and all plants and probably a lot of other organisms as well. And if you get excessive calcium signaling, that can produce pathophysiological effects. And then there's a second pathway that goes on here where you get increases in, and let me say, you don't need to remember all this stuff. What I'm trying to tell you is we know a lot about the specifics of what's going on here. You get increases in nitric oxide and superoxide, and these two react with each other very, very rapidly to form this guy, peroxynitrite. Peroxynitrite is a potent oxidant. It's not a free radical, but it breaks down to form highly reactive free radicals over here. And they, in turn, produce oxidative stress, and they activate NF-kappa B and produce inflammation. And I think probably all of these things have been discussed in other talks here. And so they then all contribute to the pathophysiological effects that occur. Interestingly, when you have modest increases in intracellular calcium instead of very large ones, you can also trigger a therapeutic pathway through nitric oxide signaling and raising the level of NRF2, and that then produces therapeutic effects. This therapeutic pathway produces effects that are almost exactly opposite what you get from the peroxynitrite oxidative stress inflammation pathway. So what that means, under different circumstances, you can get almost opposite effects from EMFs, depending on how big this calcium increase is, okay? Now there's one other thing in here that I want to mention to you, and that is that nitric oxide also has other effects, and one of them, nitric oxide binds to cytochromes, and it can inhibit their activities. And so one of the groups of cytochromes that are important are cytochrome P450s, and they then are blocked by nitric oxide. And what do they do? Well, one thing that cytochrome P450s do is they help detoxify the body from toxic carbon-containing compounds. So, so there can be a synergy between the EMFs and the and chemicals for that reason. And I'm going to talk later on about a second kind of way in which they connect synergistically as well. So I just want to, okay, so we have a lot of information about how this whole thing works in it. And the reason, oops, I'm not, oh, what's happening here? I don't understand why my, okay.
Oh, Martin, if you want, you can, and you here.
Yeah.
Oh, you just need to, yeah.
Let me, no, it doesn't want to escape. Oh, now it's going. Okay. All right. So, okay, so this paper that I published on the how you get penetrating effects, and it has to do with the coherence of these EMFs, and was published last year in May, and it's a very important paper for showing us not only sort of basic properties, but also specifically how you get highly penetrating effects, even from millimeter waves, that where the electric fields don't penetrate well, but the magnetic fields are highly penetrating. So anyway, so what we have here is a number of important things, and I've already mentioned most of them. Whereas electronically generated EMFs are coherent, most natural EMFs are incoherent. And so they only produce minuscule forces in comparison with the very large forces from the electronically generated EMFs. So that's a very important difference. It's the peak forces that produce most of the effects. And we know that from these pulsations. They are produced by these highly pulsed EMFs are much more biologically active than our non-pulsed EMFs of the same average intensities. And average intensities, which are the basis of the safety guidelines, tell you nothing about safety. So it's the peak levels, the highest levels that are the most important. So you get a number of highly penetrating effects from millimeter waves, even though the industry says you cannot get them, and that's and I discussed a number of these in here, and I'll talk about some of those later on as well. So modulating EMFs, which are used to carry information in all wireless communication except for FM radio, are very important in terms of producing much higher effects. And so the same things that are important for wireless communication are important for producing maximum effects in our bodies. And this is as I said before, average intensities are the basis of all the safety guidelines, and they simply cannot be used to predict biological effects. They simply don't work. 5G is designed to be extraordinarily highly pulsed in order to carry vast amounts of information. And that's the basis, that's the primary basis of the concern for 5G, is that it because of its properties, it produces very, very high effect.